A very good morning to you all. First of all, I would like to thank the organizers of JIRCAS for giving me the opportunity to give a talk and share my views on IIMR as Global Center of Excellence on Millets, achievements and focus areas of research. I also would like to apologize for not being present in person in front of you because of the sudden developments and the upcoming visit of our Honorable Vice President of India to lay the foundation stone for the regional research station of pearl millet in Badmer districts of Rajasthan. And that was the reason I'm not able to be present in front of you in person. And still again, I would thank the organizers for giving me this opportunity to be in front of you through the virtual mode and share my thoughts and give you the details of how IIMR is doing as Global Center of Excellence on Millets and what are the areas and focus areas of research on millets by IIMR. So as mentioned, I'm giving a brief talk about IIMR as Global Center of Excellence on Millets, the achievements and focus areas of research. We at IIMR are doing research on 9 different millets. As you all know that millets are small-seeded grasses which are grown as food and fodder. And we have 3 major millets, that is sorghum, pearl millet and finger millet. And these 3 major millets occupy about 95% of the total millet area in the world. And the other minor millets are foxtail millet, kudo millet, little millet, barnyard millet, troso millet, brown-top millet, which constitute about 5% of the total area. There are other exotic millets which are of interest to us, are teff and fonio. But for the time being, our major research is focused on these 9 major and minor millets. For the information of the House, the Government of India has renamed millets as nutri-cereals for production, consumption and trade point of view by a gazette notification that was issued on 13/4/2018. The benefit of the audience, I just would like to bring the unique selling points of millets for climate resilience, ensuring human health, food and nutrition security, because they're good for planet, because of their faster growth, shorter life cycle, they put less stress on the environment, they can be grown organically, requiring minimal fertilizers and pesticides. They survive on low water and nutrients, they need less rainfall. They're also good for farmers because they can withstand harsh environment, drought, heat, etc. Resistant to pests and diseases. They're capable of producing high yields. They could be used as food, feed, fodder, and brewing and biofuel. And they're the sustainable source of income to the farmers. They're also good for human health because of the higher nutrient content like micronutrients like iron, zinc, and calcium, high in dietary fibers and antioxidants. They're low in glycemic index and they're gluten-free, and they're high in protein and vitamin B, rich in polyphenols and phytohormones. And if you look into the health benefits of millets, because of their nutritional superiority, they help in detoxifying the body, lowering the bad cholesterol, preventing the onset of breast cancers, prevent the type 2 diabetes, reduce the blood pressure, protect against heart diseases, and respiratory conditions like asthma. They help to optimize kidney, liver, and immune system and reduce the risk of gastrointestinal conditions. And nutrition is becoming a time bomb as growing carbon dioxide level strips crops of their minerals. So the attention is now moving from the 4 major crops that were rice, wheat, maize, and soybean. And now we need to focus and divert the attention to millets. And also to accept these millets, the taste need to be changed because we all are used to some pattern of eating like with rice and wheat-based or maize-based systems. For the information of the House, the Honorable Prime Minister of India has dedicated ICAR Indian Institute of Millet Research as the Global Center of Excellence on Millets, that is Shri Ann, on 18th March 2023 at the Global Shri Ann Conference in New Delhi. Now coming to millets, if you look into the global millet stats, the global millet area is about 74 million hectares with a total production of 89.17 million tons, and 90% of this total is contributed by sorghum and pearl millet. And of this total millet production, 20% of the global millet production is coming from India. And India is the largest producer and consumer of millets with maximum diversity in terms of types of millet crops that are grown and utilized for various purposes. And at the on date, the area cultivated in millets is about 13.60 million hectares with a production of 18.02 million tons and productivity of 1,322 kg per hectare. India is the topmost producer for barnyard millet, finger millet, kodo millet, little millet, and pearl millet. And these are the major states which are growing different kinds of millets in India: Rajasthan, followed by Maharashtra, Karnataka, UP, MP, etc. So if you look into the millet genetic improvement in the country, we are doing under Indian Institute of Millet Research, that is the National Millet Research Network, wherein we have 3 All India coordinated improvement programs, one on sorghum, the other one on pearl millet, and the third one on small millets. Through different research centers that are located in different state agriculture universities, we have a number of centers working on sorghum, pearl millet, and small millets. Until date, we have about 257 central releases in pearl millet, followed by 144 central releases in sorghum, and 118 central releases in small millets. And the research carried out in these areas is through multidisciplinary, competent scientific and technical systems. So if you start with the various crops that are grown, millet crops that are grown in India, pearl millet is the major crop. And at the world level, it is occupying about 30.93 million hectares with a production of 30.09. And in India, it is occupying an area of 7.41 million hectares with a production of 9.35 million tons and a productivity of 1391 kg per hectare. And we have different product profiles, and the requirements of hybrids and populations in these areas are different. Pearl millet being a highly cross-pollinated crop, hybrids are the mainstay here. We have 4 different zones, like major one is A1 zone, which we call it is in the northwestern part of the India, covering states of Rajasthan, Gujarat, and other areas. And here the annual rainfall is less than 400 mm annual rainfall. The type of material that we target here is those hybrids and population that mature in 70 days. And the total area under A1 zone is about 3.5 to 4 million hectares. The material that we look into for this area is dual purpose, high yielding, high tillering, early maturing, downy mildew and blast resistance with seedling stress tolerance, along with iron and zinc. And similarly, in the A zone, where the annual rainfall is around 1000 mm, we go for medium duration hybrids and populations that mature in 71 to 80 days. And the area approximate is about 2 to 2.5 million hectares. And the material also will be preferred something similar to the above. Then we also have in the southern part of the country, which we name as B zone, and the area is about 1 to 1.5 million hectares. Again, the material requirement is high yielding, downy mildew, blast resistance, and iron and zinc with the iron and zinc. We have another special segment called summer pearl millet, where the material matures in about more than 80 days, and the area is around 4 lakh hectares. And again, the material we prefer is of this type, along with iron and zinc. I just would like to bring to the notice of the audience that we are moving from food security to nutritional security and are also mainstreaming the nutritional traits. And this is for the first of its kind decision and a policy decision in the world in control development, wherein iron and zinc have become the part of promotional criteria in our all India coordinated pearl millet trials. We have fixed a benchmark level of grain iron 42 ppm and grain zinc 32 ppm. Any entry which is contributed and is being tested in the coordinated trials should have this much of iron and zinc in spite of the yield. If they doesn't have these much of minimum levels of 42 ppm iron and 32 ppm zinc, they're not going to be promoted to the next level of trials, or they will be identified, nor they will be released. Till date, we have released about 40 hybrids starting from 2018 onwards with a minimum of these levels. And we have material with iron and zinc as high as iron 77 or 83 ppm and zinc to this. And we have many materials which are having even 50, 55 ppm zinc as well. And if you look into the production productivity trends in pearl millet since 2000, since here, 51 for 55, if you take the average year of 5 years, starting from 51, 55 till 2020, you can see there is a constant improvement in the productivity. And the next important millet crop we deal with is sorghum. The sorghum, it is about cultivated in 41.55 million hectares at the global level with a production of 64.36 million tons and productivity 1548 kg. And in India, we have grain sorghums and forage sorghum. This is the area, and this is the production and productivity level. The production systems of sorghum, we have Kharif grain sorghum, that is rain-fed, then Rabi grain sorghum, that is the post-rainy season, summer grain sorghum, that is grown in rice fallows and zero tillage, and then forage sorghum, whether it is a single cut or a multi-cut, and then sweet sorghum, that is for biofuel production. So these are the major states which are growing different kinds of sorghums, and this is the extent of area, and these are the yield levels. And these are the product profiles. We have extra early types, medium type, rice fallows, depending on the purpose and the maturity durations. We have already identified, and the breeding efforts are going in this direction because these target to the niche area and the target ecologies. So these are the popular latest Kharif grain sorghum hybrids that have been released. And these are the Kharif grain sorghum varieties that have been identified and released for cultivation in different parts of the country. And these are the post-rainy sorghum product profiles with early duration and medium duration types. And then we have different, again, product profiles identified for single cut sorghums and multi-cut sorghums. Then rain-fed semi-arid conditions, arid and semi-arid conditions, and both in single cut and multi-cut. And these are the parameters we look into with a minimum of crude protein this much, and then in vitro dry matter digestibility to this much extent. So all these parameters are incorporated into our product profiles. And sorghum, we also take it as an industrial crop, and then because it has a big scope for food and starch industry and poultry and all portable alcohol development and all these things. And we also have our efforts going on towards development of high sucrose sweet sorghums that would be used for bioethanol. Coming to the next important millet is finger millet, and here we have three different major productive zones identified, and these are the areas and these are the varieties identified for that. Finger millet here, it is grown in about 12.32 lakh hectares, that is 1.232 million hectares with the production and productivity of this. And in the global level, it is grown in about 2.2 million hectares. In finger millet, recombination breeding is very tough because of the very small size of the spikelets. And even when we try to study the floral biology, the time is about something around early hours, very early hours, like 2 o'clock to 3:30, which is very early in the morning. So it becomes very tough for the breeders to create variability by using recombination breeding. And our scientists were able to standardize the hybridization technique using hot water method. And these are some of the promising kind of material developed through recombination breeding using different lines. You can see variation in grain filling, then pigmentation, lodging type, number of fingers and long fingers, short fingers. You can see all kinds of variability created here. Here also we have the product profiles based on the maturity groups for southern part of the country and the northern part of the country with the different maturity groups, early, medium, late, irrigated and other ecology types. And these are the popular newly released finger millet varieties, and these are the biofortified finger millet varieties with enhanced micronutrient contents, and all these are done only through conventional methods. The next important small millet is foxtail millet. This is again a short-term medium duration millet, and these varieties are really responsive to the nutrient management. And in India, this is grown in about 13,990 hectares, and at the global level, it is grown in 10.57 lakh hectares. And these are the areas in the country which are taking up foxtail millet cultivation. Here we have two kinds of product profiles, early duration and medium duration. These are number of varieties are released in the country. And these are the important varieties that were released in the last 10 years. The next important millet is barnyard millet. This is majorly grown in India, and this is the extent of 0.594 lakh hectares with a production and productivity of this much. And it is very rich in dietary fiber content, and also it has a very low glycemic index. We have different production ecologies like northern hilly region and southern plains, and these are the different parameters we look into when we go for breeding of barnyard millet. These are the latest improved varieties in barnyard millet. Then next is the proso millet, which is very high in protein content. It is majorly cultivated in India, then US and other countries. It is almost cultivated in about 30 plus countries in the world. And the latest improved varieties are these. And the beauty of proso millet is it is a very short duration millet, and it can fit into any of the cropping systems. The next important millet is the kodo millet. This is highly adapted to hilly ecology and salinity, and it is tolerant to stress. It is rich in dietary fiber, and these are the latest improved varieties. The toughest part of this is that it is very tough to breed kodo millet varieties, and it is a challenge to the millet breeders. The next important millet is little millet. These are the breeding objectives we look. We have different kinds of races, Nana type, Robusta type, and these are the latest varieties which are released in the little millet. And these are the newly released little millet varieties. Apart from the conventional breeding, we also use modern tools which are part of our millet improvement, like marker-assisted breeding. We go for transgenics, though they have not yet released, but the technology is available. We have not yet released any transgenic variety, but the technology is with us. Then genomics, speed breeding, genome editing, these are also part of our ongoing breeding programs. And if you see in the past 10 to 12 years, the number of cultivars that are released, and these are the national releases in different millet programs. And if you see, in spite of the reduction in the area, the productivity is constantly increasing because of the continued efforts of the millet improvement and through the millet breeders, and also the availability of quality seed through seed production systems. Apart from the crop improvement, the major effort we also put is in collection of the millet, collection and maintenance of the millet genetic resources. And this is the status of the global status of millet holdings. And these are the informations of the germplasm available at the global and national gene banks. We have a medium storage, medium conservation of germplasm at Indian Institute of Millet Research. And these are the registered millet genetic stocks in different times, in different millets during different years. We have a large, beautiful amount of variability in different millets. And the seed production in millets is taken up by the breeder seed organizations, that is through universities or the institutes or the companies, then seed growers, farmers, self-sown seeds, and the type of cultivars we have in millets are the highly cross-pollinated, like pearl millet, where we have the hybrids, composites, and varieties, and then often cross-pollinated in millets like sorghum, where we have two-way hybrids and then varieties, self-pollinated. Remaining all millets are self-pollinated, and we have varieties. And apart from these crop improvement activities, we also are involved in production of development of technologies and transfer of technologies. So our millet extension research and outreach is also very phenomenal, wherein we do assessment and dissemination of production technologies developed through farm research system, and then diversify the millet-based farming. We help in extension of millets in tribal area and rice fallows and all these things through different apps and different procedures. We also have we have been promoting millet through farm collectives like KVKs, that is Krishi Vigyan Kendras, or the farmers producers organizations, or through frontline demonstrations and identifying the new niche areas. And this is our millet farmers producer organization model of ICAR, where we identify the farmers, we identify and supply them the farm input, or we also provide the market accessibility. We help them in processing and value addition. We help in storage and warehousing of the millets. We help in aggregation. We also provide the custom hiring centers and loan credit systems. We have already standardized and developed millet processing machinery that is useful for primary processing and secondary processing. And we have helped in coming out of drudgery of millets, and we have developed about 67 millet-based value-added products and commercialized these technologies. These are some of the machinery that are used in primary processing. And if you see in primary processing, we have value addition technologies also, primary processing, secondary processing, advanced processing. In primary processing, we can go for flour preparation, semolina, dehulled grain. Secondary processing, flaking, baking, puffing, extrusion. Advanced processing, we have dairy analogs, meat analogs, composite foods, nutraceuticals. We have a number of millet value-added technologies, starting from millet flour to millet noodles. And IIMR has broken the inconvenience through innovation by nutritional profiling, product-specific cultivars, coming up with diversified technologies, then tackling the absence of gluten and using starch manipulation, then developing composite foods, plant protein, which is the need of the present day conditions, and all these things. And these are some of the technologies we have used, like puffing, flaking, baking, cold extrusion, hot extrusion, fortification, instant mix technologies, recipe development, and all these things. And we have millet recipes that are coming up with contemporary recipes, the breakfast recipes, main course recipes, snacks, sweets, desserts, or traditional recipes, or the international recipes. And some of the international recipes, we have come up with 108 recipes prepared from Asian cuisine, American cuisine, European cuisine, African cuisine, Australian cuisine, and also 600 plus recipes are developed by IIMR using the traditional things. And we have our own brand called Ready to Eat products, and Eat Right is the brand name for the products developed by IIMR. And we have a technology business incubation called NutriHub, which is helpful in handholding the upcoming startups and entrepreneurs and guide them in establishing businesses based on millets. During this handholding, we have both backward and forward linkages for promotion of millets involving farmers, consumers, promotional activities, R&D activities, food processing, entrepreneurship development, and all these things. And we have a number of startups supported by NutriHub of IIMR, which till date we have about 400 plus startups, and these are the technologies that have been created and supported and all these things. We have two core programs which support the upcoming entrepreneurs, through NEST, which will give you a funding support of 5 lakh rupees, through NGrain, which can support up to 25 lakh rupees. And we are also involved in development of standards for food safety and standards. And recently we have come up with these standards and they were released by the Honorable Prime Minister. These are the details. We are also involved in the policy advocacy through white paper on millets, then strategy position paper on mainstreaming millets, then position paper for planning of actions of programs as run up to IYM 2023, then millets, mainstreaming millets for nutrition, improved livelihoods, and others. So what IIMR can give or offer to the world through our Global Center of Excellence? So we can come up with technologies that would be helpful in enhancing production and productivity, scaling up of millet value chains, South-South cooperation, mainstreaming of millets, and extension outreach. And apart from this, IIMR also will be the secretariat for the Maharishi, that is Millet and Other Ancient Grains International Research Initiative, that was approved in the G20, and it has come in the New Delhi Leaders Declaration. And all of you are aware that the government of India has rebranded millets as Shri Anna because they are a big foundation for the chemical-free farming. They help in fighting climate change. They facilitate tribal communities. They are a door to the prosperity for the small farmers of the country. They link villages and the poor, and also they are the medium for holistic development of the country. Hence, our Honorable Prime Minister has rebranded these millets as Shri Anna, that is the superfood. And we have a 7-pronged approach to put millets on every plate. So the things we deal with are nutrition and health benefits, value addition, processing and recipe development, international outreach of millets, then awareness creation, branding, labeling and promotion, policy interventions, enhancement of production and productivity, entrepreneurship, startup and collective development. So eat millets and stay healthy. And thank the organizers for giving me this opportunity. And also thank you all for your kind attention.
Good morning, Mr. Koyama, President of JERCAS, Mr. Uchida, DDG, Agriculture, Forestry and Fisheries Council of MAF, Ms. Hibi, Director of the FAO Liaison Office in Japan, colleagues and friends in the audience today. Many of our global challenges, some in agriculture, some are beyond and global, but they affect us all. We're in the UN International Year of Millets, and I am lucky to be the Vice Chair of the FAO Steering Committee. And what crops other than millets could be more important in times of climate change and food and nutrition insecurity? I would thus like to talk about millets, agriculture, food and nutrition in a changing world. Briefly, I would like to explain about ICRISAT. We're an international non-profit agricultural research institute with a focus on dryland farming systems in Asia, Africa, and beyond. We were awarded the Africa Food Prize for 2021 as a result of work with our partners on the Tropical Legumes Project from 2007 to 2019, where 266 improved legume varieties and almost 500,000 tons of seed for a range of legume crops, including cowpea, pigeon pea, chickpea, common bean, groundnut, and soybean were produced. 25 million smallholder farmers became more resilient to climate change and to pest and disease outbreaks because of this project. The project also trained 52 scientists who are already working in their respective national programs. The picture shows our headquarters in Hyderabad, India, spread over 1,390 hectares, beautifully landscaped with precision research fields, water bodies, and world-class research facilities. We were 50 years old last year and celebrated in the presence of the Honorable Prime Minister of India, Narendra Modi. As well as the headquarters in Hyderabad, you can see from the map where we are hosted in Africa, from Ethiopia to Mozambique, Tanzania to Mali. And we have project offices in other countries. We're opening an office in Sudan. We have offices in Saudi Arabia and Senegal. We're expanding our reach and impact further. Apart from millets, and in the International Year of Millets, sorghum is also a millet. We work on the challenges that we see daily, and these include the ones listed on the left, but this is not an exclusive list. Many of those challenges that you see result from the number of people we're going to have to feed and nourish. And there are other activities such as agriculture, industry, and conflict that add to these. The Sustainable Development Goals are clear, and almost every country is working towards achieving the goals. However, in some areas, we seem to be going backwards. Why are there another 46 million people going to sleep hungry? Why is more land degraded when we're supposed to be trying to nurture and improve our arable land so that we don't need to cut down more forests? Why do we still have problems of market access and gender inequality in a world that prides itself on digitalization, facilitating policies and good governance? At ICRISAT, we're addressing these issues by improving the productivity and resilience of our crops. I've been encouraging our breeders to use new technologies for the now and to focus on conventional breeding for the future, the 5 to 10 years ahead future. And one of the technologies for the now, gene editing, I'll discuss in a moment. We also need to improve the soil health. We need sustainability. We need to regenerate our soils with an understanding that any yield we remove from the ground is removing nutrients from the soil. We're looking at a dire future where we're going to be expected to grow nutritious and high-yielding crops on poor soils with fluctuating temperatures and with minimal or saline water, not to mention the climatic shocks from the extreme weather events. This is a daunting challenge. Let me tell you about some of our work, especially on the millets. This is an image of our gene bank on the left, where we have over 129,000 accessions of our dryland cereals and grain legumes, conserved under the International Treaty for Plant Genetic Resources for Food and Agriculture, in our gene bank at headquarters and in 2 regional collections in Africa. These are all safely duplicated in 3 other gene banks and over 90% in the Svalbard Global Seed Vault that you see on the right. We've repatriated germplasm to 9 countries and have just received yet another request. And over 1.5 million seed samples have been shared with 149 countries. Our global millet reach is such that for sorghum, pearl millet, finger millet, our partners have released 651 varieties with us. Some sorghum varieties, for example, sweet sorghum, are used for industrial work, production of ethanol for industry, for example. And some varieties of millets are dual purpose, providing fodder and grain. In the drylands, animals are incredibly important and also require food and nutrition. In our small millets work, our work is mainly around breeding programs and agronomy. But let me get back to the gene editing that I mentioned earlier. That is part of the breeding for the now. On the 30th of March, 2022, India issued a memorandum for the exemption of SDN1 and 2 categories of genome-edited plants free from exogenous external DNA, which means that their use is no longer restricted in India. We can therefore release materials with the national partners, which is gene edited, so long as we follow some basic regulations around their public use. One of the biggest issues with pearl millet, it's nutritious, that's not the issue. The issue is their rancidity, the rancidity and bitterness of the grain. The grain will last for about 8 weeks at 45 degrees Celsius. And 45 degrees Celsius is a temperature that is very common in India and other parts of the world. If you can afford refrigeration, the seeds, the grain will last about 15 weeks before going rancid at 5 degrees. That's not very good characteristics for what should be a global crop in a globalized market. The flour is even worse. The shelf life is 5 to 10 days because of rancidity. There is some pre-treatment possible, but not everyone can achieve the levels of pre-treatment required. We're very pleased with the editing and regeneration efficiency that we already have, as it sets the stage for ramping up the editing work in pearl millet. What you see in the table is the work in progress, where we're working at speed to develop gene-edited lines to permit pearl millet flour to have a longer shelf life and be more appropriate for regional and global markets. Sorghum also has an intractable problem. Striga. In the picture on the right, you'll see the really beautiful flowers of striga. Striga then produces tiny seeds like dust, and striga is a parasite that is lethal to the crop. We're looking at the strigolactones produced by the crop. Strigolactones are endogenous hormones to control plant development, so very important. They're components of root exudates that allow symbiotic interactions with the soil microbes. However, these strigolactones also stimulate the weed seeds to germinate and attach to the roots of the host plants. Gene editing is currently being done along the strigolactone pathway to edit for striga resistance. Now let me move to BNI, biological nitrification inhibition. Subarao and his team from JIRCAS will discuss this later, but let me just give you a brief introduction. Our work with JIRCAS was initiated about a decade ago. Biological nitrification inhibition could be a great strategy to conserve nitrogen in poor soils. These poor soils are very common in the drylands. And we're working with sorghum because of its very high inherent inhibition activity. In our work around sorghum, the main BNI compound in sorghum, our JIRCAS ICRISAT collaboration has been around the development of the genetic stocks and our germplasm sets that we have based on the gene bank and beyond. As you see, there has been some progress, and as I said, Subarao will no doubt discuss this in detail, but the germplasm sets include 231 genotype reference panel, 137 genotypes from our West Africa panel. In the GWAS reference set and the picture on the right, you'll see a sorghum activity around chromosome 7. I'm sure you'll hear more about this from the JIRCAS team in a moment. What I want to highlight, though, is that we don't only work on sorghum for BNI. Another proposal has been successfully received by the Novo Nordisk Foundation to continue our work with sorghum. We also work with pearl millet on BNI with the University of Vienna and, of course, JIRCAS, and starting to investigate our other millets and genetic diversity that we hold. So I've been talking about the micro scale. Let me move to the macro. Climate change is happening, and we can all see and feel it. We need to adapt and mitigate. While paddy rice is perhaps a key target to mitigate greenhouse gas emissions from agriculture, we can all do our part with our crops and our locations. We're going to need agriculture and crop management techniques to protect our crops and productivity, as we do for humans against heat and cold, wet and dry, for example. We need adapted crop varieties, adapted for the future, a future we can only project and extrapolate for, and sometimes it's even hard to imagine what that future might be. To mitigate climate change in the drylands, we look towards agroforestry and conservation agriculture, carbon credits, and ecosystem services, which apply just as well to the drylands as to the jungles and forests where we've heard so much about it. Adapting and mitigating are just two aspects of working around climate change. We need climate resilient farming, climate smart agriculture, and sustainable agriculture. Remember, we don't just work on one crop, one field, nor even crops on a farm. We work in agricultural systems, and it is those systems and their diversity that can provide sustainability and buffering. We need to understand the systems, their interactions to be able to maximize resilience. Using digital tools, we can satisfy those farmers with better advisories, access to markets, to information, and provide data and models for effective policies to be developed and implemented. So if you look now, I'm looking more at the digital and the precision work of farming. Digital tools can take us even further down the resilience route. We can work with remote sensing and Internet of Things to use land, water, and other inputs more effectively and efficiently. Digital tools are vital for extension workers. Digital platforms can be used to provide better information for loans, to link farmers to markets, provide support for export markets, for insurance systems. Some of the digital tools that ICRISAT has developed with partners are particularly apt for the millets. Plantix, the first on the left there, is for farmers to manage pests and diseases. I also use it at home in my vegetable plot. The second one, Megdoot, is a weather forecasting app for the 60% of Indians who are farmers. Mrida is a soil health app with a digital board game embedded in it. And on the right, ICAR, the Intelligent Agricultural Systems Advisory Tool, supporting farmers' decisions through the crop cycle. There are many other digital tools, but these tools can help the youth perhaps become more interested in agriculture when the lights of the big cities seem even more irresistible. As we look at overall sustainability, in addition to considering the soils, we need to look at soil carbon specifically and carbon farming. We need to look at the traditional farming, where we can hope to decrease water use, inputs, emissions, and we need to measure and monitor as we do so. Simultaneously, we need to increase the regenerative agriculture, water quality, nutrient efficiency, and ecosystem services, with equally good measuring and reporting and verification systems. A decrease in the negative aspects and an increase in the positive of carbon farming is a win-win for our world. We need to conserve biodiversity. Numerous losses resulting in imbalances in pest management, pollinators, soil fertility are happening. We need to remember that we live in the environment, in ecosystems, and a huge diversity of macro and micro flora and fauna. We want the environment to be pleasant. We want to look outside, go outside and enjoy our environment. But we need that environment to be productive, agriculturally productive. And therefore, we require diversity. When I talk about soil fertility, let's also go on to soil health. At ICRISAT, we've got many soil tests, tools for mapping, apps for farmers, but this still requires capacity development on the ground, facilities to test soil, to validate the results, ensure appropriate recommendations. We use a build, operate, and transfer model for these soils laboratories. While we directly look at soil quality and composition, we need to assess and improve soil regenerative ability. Many of our soils are severely degraded. How can we improve them, and really quickly? At present, this would be particularly through scaling known technologies for us in the drylands, which is a focus because of the International Year of Millets. Part of that regeneration of soils is through managing water. In the Bundelkhand of India and the Afar Valley of Ethiopia, for example, we've managed to help the local communities engage around soil erosion, harvesting and retaining water, particularly from rainfall, improving soil moisture levels, truly greening the drylands. This is important because even millets, which we say grow in poor soils with minimal water, do at least need a basic amount of soil moisture to grow. A little more water and a little more nutrition will allow them to thrive. It's one thing to produce millets, but we have to remember what happens after harvest. We have to reduce losses after harvest in the field, in the market, processing, in the home, and on our plates. We have business models that can help minimize losses along the value chain, market linkages which connect every link along that chain. The transparency and availability of information is critical. The need to add value to the crops, which was known as the poor farmer's crop. It's a must. In India, this is being done by rebranding millets as Sri Anna, which translates somewhat as the food grain which has divine grace. I also call millets the food of our future. Millet-based products need to be consumer friendly and also friendly for the industries, whether it's to produce fiber-rich prebiotic foods, protein-rich foods, extruded snacks, nutraceuticals, nutritional supplements, and fortified foods. Millets are a powerhouse of all these products if they are used properly. Many of us sitting here today are habituated to fast food. We have a fast-paced life. We don't have much time. We need fast food. Fast food can and should be healthy. Look at these two quick examples here in this image. Towards the middle of the screen, there is microwavable sorghum. This sorghum rice, if you were making it yourself at home in a rural area, you'd be soaking your sorghum for many hours, 6 hours or so, and you'd need over an hour of cooking. But look at this, a sachet, like the sachets of rice that you have in Japan. Just tear open the pack a little bit, microwave for 1 minute, and you have sorghum rice. Also on the right, novel millet milk. You've had almond milk, I'm sure, maybe cashew milk. Millet milk, it's pretty good. Many of those involved with millets are women. And they may or may not be from tribal communities, but most likely they are disadvantaged or part of the truly disadvantaged communities. Women comprise half of the world's population and provide somewhat over 60% of on-farm labor, sometimes even often unpaid or very lowly paid. And yet they're sidelined quite a lot in our research activities. We need to ensure that gender, and I'm speaking to the researchers now, is not the last additional paragraph in your project proposal so that the donor can tick the researcher has looked at gender box. We need to promote women's inclusion with the men so that women have access to resources to improve their lives and livelihoods, which will at the same time improve the lives of their families, their children, and their communities. To do this, women and men need to have information and capacity development. We need to ensure that information is available, and in the case of millets, that new information which is generated as a result of the International Year of Millets, in particular, has been made available, accessible as well. That is even more important. Farming is a very risky profession, and we need to help mitigate those risks, especially with these crops which have had a less than stellar background, partly due to the way they're grown and also to the quality of the produce sometimes. Local communities have some of the answers. Global research networks, other global networks have some of the answers, and consumers know what they want. Bringing people together will help us solve apparently intractable problems and help guide national policy formulations. So these policies, always a tricky area, but ICRISAT and our many partners in this International Year of Millets, and with our 50 years of experience in dryland cereals and grain legumes, have been fostering the networks that allow sharing of information. You see here that there have been conferences, sensitization programs, seminars, policy briefs, and beyond. Our next big event will be the India-Africa International Millet Conference to be held in East Africa later this year. It will encourage South-South collaboration and exchange, which is very important. Getting technologies from one country in the South to another is often difficult only because of the distances involved. And we need to achieve this. This exchange will help promote the world's emerging smart foods, millets. In summary, we must treasure the diversity of millets and within the diversity of a sustainable cropping system. We need to use the best technologies available to help bring millets to the level of the global three: wheat, rice, and maize. Millets are better adapted to our changing world, our changing climate, than these three crops. When we work as researchers on millets, we must not forget their current growing conditions may become the growing conditions of many of us in the future. These millets, all our crops, will need to yield much better, more sustainably in their current conditions, but in the conditions with which we that grow millets are very familiar, the hot and the dry. These dry lands we know are expanding already. Digital tech will become increasingly important. We hear that knowledge is power. Shared knowledge is even more powerful. Conducive policies, not just policies, but conducive ones, will be pivotal to the success of millets, which are full of nutrients and provide other health benefits, as well as growing in difficult conditions. And they should be reducing the exploitation of our forests and other lands for food production. Millets, smart food, good for you, good for the farmer, and good for the planet. Finally, I hope that you will enjoy the full range of millets, their different uses, their health benefits, and the wonderful tastes and textures that they have. Thank you very much for the opportunity to be able to join you today and to share this information and my thoughts with you. Thank you very much.